Hi ladies and gentlemen, it's Mr. Green again. It's time for another in my lessons on Algebra 2. So let's go forward and see what we're looking at. We're working through Chapter 7, getting close to the end of it. So everyone be aware, unit test approaching, end of semester approaching. So you got to be very, very careful with that. Okay, where are we at? Well, we want to look at how would we solve some equations using complex solutions. Well, if you look at a quadratic equation like this one that's over here on the side, you notice it never crosses the x-axis, so it doesn't really have any real solutions. It's got complex or imaginary solutions. Okay? So we're going to use the quadratic equations and we're going to find some complex solutions to these quadratic equations. So let's just start off by saying, well, solving a quadratic equation with real solutions, if you take the square root of both sides of an equation, you're going to get plus or minus a, or plus or minus the square root of a, where a is greater than 0, for a solution. For this example right here, I would first of all divide by 4 to get rid of that 4 in front of everything, and I would have an x squared is equal to 20. And then I would say the square root of x is x, and that's equal to plus or minus the square root of 2 square roots of 5. I rationalized it already because it's 20. 4 times 20 is 4 times 5 is 20, so the 2 comes out, the 5 stays in there. So I rationalized it. There's my real quick answer. So let's check these. If we use the positive version, 2 square roots of 5, and I'm going to square that. Okay? Well, and I multiply it times 4. Well, 2 squared is 4. 4 times 4 is 16 times 5. 16 times 5 is 50, and 15 and 30 is 80. Check. That one checked out. So let's use the negative version of it. So we've got 4 times negative 2 square roots of 5 quantity squared. Well, inside of the square root signs, the negative becomes a positive. The 2 becomes a 4. We get 4 times 4 times 5 again. 16 times 5, 16 times 5, which is equal to 80. Check. They both checked out. So that would be my solutions to this particular problem. Okay? Let's move forward and look at another issue here. What happens when we get a negative number on the other side of the equation? Then when I take the square root, I've got a problem. Okay? And that problem is that we don't wind up with a real solution. We wind up with an imaginary one. So I'm going to solve this problem real quickly. And if I take and divide both sides by 3, I get x squared is equal to negative 7. Because I subtracted the 21 from both sides, divided by 3, I got negative 7. So I take the square root of it, and I get x is equal to plus or minus square root of 7 I times the square root of 7. Well, I've got a positive and a negative number there. I want to check them and make certain they're right. So that's going to be 3 times I square root of 7 squared. Well, that's going to give me 3 times I squared times 7. Well, 3 times 7 is 21. I squared is negative 1, so that's going to be a negative 21. Guess what? If I had added 21 on here like I was supposed to, then I would get 0 as my answer, and that checks. That's the correct thing. So let's look at the negative version of it. So 3 times negative I square root of 7 squared. Well, that's going to be 3 times negative I squared times 7. Well, that's 21. Oops, plus 21. Forgetting to do that both times. Okay? That's 21 and negative I squared. Well, I squared is negative 1. Negative squared is a 1. So that's going to be I believe, a negative I squared is a positive 1. Negative I times negative I, positive I squared. Nope, that'd be a negative 21. Negative 21 plus 21 gives you 0. Check. That would be my answer. Okay? So we're seeing how to find those. So let's see what we can do to find a few more answers here. What if we have this? Well, I'm going to take the square root of both sides. I'm going to get x plus 3 is equal to the square root of 5 times I. And then I'm going to subtract 3 from both sides. I'm going to get x is equal to a minus 3 plus or minus I square roots of 5, square root of 5I. Okay? So if I wanted to check this one, I'm going to stick that into the equation, right? So what am I going to get? I'm going to get x plus 3. Well, wait a second. I want to substitute that in. So it's minus 3 plus I square root of 5. Okay, and that's going to be squared. Well, when I square that, I'm going to get, let's see here, negative 3 times negative 3 would be a 9. Negative 3 times that would be a minus 3I square roots of 5. And it's going to be 2 of them, so it would be 6 minus 6. And then that'd be a minus or plus 5I squared. Well, 9, and this is going to be a minus 5. That's going to be a 4 minus 6I square roots of 5. Wow, that's nowhere near 5, is it? Let's try the other one, okay? Oh, wow, Mr. Green. Just looking at what I did there. I really messed up on that one. Let's try that again, okay? I apologize, guys. I multiplied that all wrong. Let's try that one again. Happens every once in a while. X, that'd be minus 3 plus I square roots of 5 plus 3. And I'm going to take that whole thing and square it. Well, the plus 3 and the minus 3 are going to cancel each other out, and I've got I square roots of 5 squared. That's going to be 5I squared, which is equal to negative 5. Check. Okay. Got to be more awake than that, Mr. Green. Sorry. Let's use the negative version of it here. We're going to get the similar type thing. Minus 3 minus I square root of 5 plus 3. Well, these are going to cancel each other out. And what are we going to left with? Minus I square roots of 5. And that's I squared, because negative times a negative is a positive. I squared square roots of 5, and 5 square roots of 5 squared is 5. That's squared, okay? So that gives me negative 5, and check, that's the right answer. Okay? Now I want you to notice over here in the tip, when we're getting these solutions, they almost always appear as conjugate pairs. So in this situation, that's what we would call this, a plus and a minus like that, a conjugate pair. And so they're almost always going to be like that. Cool. Okay. Here they're wanting me to write a polynomial equation. Okay? And they're giving me that z plus or minus 8. That means I've got z plus 8i equals 0, or z minus 8i equals 0. Right? And if I wanted to get a polynomial from that, I could multiply those together. I got z plus 8i times z minus 8i. Well, I can see we've got the classic difference of squares there. So that's going to be z squared minus 64. that positive times a negative, negative 64 for I squared. Okay? So I squared, that becomes a positive, so I would have z squared plus 64. And that would be equal to 0. That would be my equation that I would have come up with for the function z. P of z would be equal to z squared plus 64. Cool? Let's try it with a little bit more complex number here. So what is that going to be? That's going to be z plus 3 plus I square roots of 7 times z minus, z plus 3 minus I square roots of 7. Okay? So basically we're going to have to multiply everything times everything in here. So I'm going to multiply the z times everything on this other one, and I'm going to get a z squared plus 3z minus I z square root of 7. And I'm going to get a 3 times everything over there plus 3z plus 9 minus 3I square root of 7. And I'm going to multiply the I square root of 7 times everything. I'm going to get a plus zi square root of 7 plus 3I square root of 7 and a, let's see here, negative I squared 7. Well, the negative I squared is going to become a positive 7 there. Okay? So let's look at what we've got. I see here, I'm going to collect my z terms here. I've got a 3z, I've got a 6z. That's all I can see right there. So I got z squared plus 6z, and I'm going to mark off the ones that I'm adding together already. Okay, I've got a 9 right there, and I've got a 7 out here at the end, so plus 16. I've got a minus iz7. I've got a plus iz square roots of 7, so those are going to cancel each other out. I've got a minus 3i square roots of 7 and a plus 3i square roots of 7. Those are going to cancel each other out. And so what am I going to be left with? Just this. And that would be my function. You see how those cancel each other out? And basically what we're left with is just the function that we wanted to come up with. Okay? So having showed you all that, you guys are welcome to come and ask questions about this. Complex numbers, imaginary numbers is a complex topic. I don't expect you guys to have understood all this every single time. Please make certain you're asking questions. I'm available to you. I'll see you